Artificial intelligence. You hear that term everywhere. But what does it actually mean? Forget the sci-fi movies for a second. AI is a seriously powerful technology that's already changing our world right now. So in this explainer, we're going to pull back the curtain and break it all down layer by layer. Ready? Let's get into it.
First off, the crazy thing is you're already using AI probably every single day. That Netflix suggestion that's just eerily perfect? Yep, that's AI. When you ask Alexa to play a song or your phone unlocks just by looking at you, AI again. Even the tech behind self-driving cars, it's all powered by this stuff. It's not some far-off dream. It's here, working behind the scenes.
Okay, so we know it's all around us, but that leads to the really big question, right? How? How does a machine, a piece of code, actually act, well, intelligent? I mean, how does it go from a bunch of raw data to making what feels like a smart decision? To figure that out, we've got to unpack a few of the core ideas. So let's start by clearing up some of the confusion, because there's a lot of jargon out there. You hear these terms, AI, machine learning, deep learning, and they're often used like they're the same thing. But they're not. They actually fit together in a really neat way, kind of like a family tree.
At the very, very top of that tree, you have artificial intelligence, AI. Think of this as the big, grand vision. It's the whole field. The main goal of creating machines that can do things that normally require human intelligence, like solving problems or learning new skills.
Now, nestled inside AI is a specific approach called machine learning, or ML, and this is a really big deal. Instead of trying to write a million lines of code with rules for every possible situation, with machine learning, you basically give the computer a ton of data and let it figure out the patterns for itself. It learns without being told exactly what to do. And if we go one step deeper, we find the real powerhouse behind the recent AI explosion, deep learning. This is a special, supercharged kind of machine learning that uses something called neural networks, which are loosely inspired by the human brain to learn from absolutely massive amounts of data. This is the magic that lets an AI understand your voice or recognize a face in a photo. So probably the easiest way to remember all this is to picture one of those Russian nesting dolls. AI is the biggest, outermost doll. You open it up, and inside you find machine learning. And then at the very heart of it all is the smallest, most powerful doll, deep learning. That's where almost all the exciting action is today. All right, so we've gotten to that innermost doll, the neural network. Let's crack it open and see what's inside. How does this so-called artificial brain actually tick? What's it even made of?
And this is just so cool. The inspiration for all of this is us. On the left here, you can see a real biological neuron from a human brain. On the right, that's its artificial counterpart. It's really just a simple little mathematical function. One is wet and biological, the other is pure math, but the fundamental idea is the same. A small unit that takes in signals, processes them, and then passes on a new signal. So what is actually happening inside one of these little artificial neurons? Well, it's basically doing a quick little calculation. It gets a bunch of data as inputs, then it weighs each piece of data to decide how important it is. It fine-tunes things a bit with something called a bias, and then it makes a final decision. Does it fire and pass a message on, or does it stay quiet? That's pretty much it. Now, that whole concept of weights can feel a little abstract. I get it. So here's a great way to think about it. It's like you're baking a croissant. The weights are like the recipe, the ratio of flour to water. They control how much importance the neuron gives to each piece of information it gets. Get the recipe just right, and you get a perfect croissant. Get the weights just right, and the AI makes an accurate prediction. So there are two main dials that each neuron can turn to learn. Weights are the first dial. They change how important any given input is. Biases are the second dial. They act more like a general nudge, kind of shifting the neuron's tendency to fire one way or the other. You absolutely need both of these to give the network the flexibility it needs to learn complex patterns. You know, a single neuron is just a tiny calculator. It's not that impressive on its own. The real power, the magic, comes when you link millions or even billions of them together into a network. But how does that giant web of calculators actually learn to do something useful? Well, it all comes down to a process we call training. Let's make this super simple. Imagine you want to teach an AI to recognize a leopard. You do it pretty much the same way you'd teach a little kid. You show it thousands and thousands of pictures that are all labeled leopard. The network tries to find patterns, spots, ear shape, whiskers. Then it makes a guess. And here's the most important part. Every time it gets it wrong, a signal goes backwards through the entire network, telling every single neuron to adjust its little settings just a tiny, tiny bit to get closer to the right answer. That process of learning from its mistakes is called backpropagation, and it's the secret sauce for how these things learn.
And even though the brain is the inspiration, it's wild how different they are. Artificial networks are unbelievably fast at math. We're talking nanoseconds. But they are total energy hogs. The human brain, on the other hand, with its 86 times billion neurons, runs on about 20 watts of power. That's less than a dim light bulb. Our brains learn through this amazing biological process of neuroplasticity, while the machines rely on that pure brute force math of backpropagation.
So, after all that complexity, the main goal of training is actually really simple. The whole process is just a massive search for that one perfect combination of settings, for all the weights and all the biases in the entire network that makes the fewest mistakes possible. Now, to give you a sense of the sheer scale we're talking about with modern AI, just take a look at this number. 70 billion. What on earth could that be?
That's how many of those little adjustable knobs, the weights and biases, are inside some of today's biggest AI models. The technical term for them is parameters, and that's what we've been talking about this whole time. The mind-blowing power of these models comes from finding just the right setting for every single one of those 70 billion parameters. It's just staggering.
So let's just do a super quick recap. AI is the big dream of intelligent machines. Machine learning is the specific approach of learning from data. Deep learning is the superpowered engine using neural networks to do it. And how do those networks learn? By constantly adjusting billions of internal parameters, those weights and biases, until they get things right. So we've seen the engine. It's this incredible system that can tune billions of tiny mathematical knobs until it masters a pattern. But as this technology gets more powerful and woven into everything we do, it brings up some really big questions. How do we make sure it's fair? How do we build it so it's transparent so we know why it's making certain decisions? And maybe most importantly, how do we make sure that this powerful new tool is something we can actually trust? That's the next big challenge we all have to think about.